Sometimes it's difficult to tell the truth value of a conditional. So mathematicians have created related conditional statements that can oftentimes help us determine the truth value. Before we begin talking about those related conditional statements, however, let's talk about what we mean by negation. It is the opposite of an original statement. The symbol for a negation is the tilde symbol. You can see the yellow tilde there before the P. We will read this symbol as not P. And as a quick example, let's use this sentence, the sky is blue. That is our original statement. And you guessed it, the negation is the sky is not blue. So with that, let's start talking about these related conditional statements. Here is our original conditional. We'll just use our hypothesis and conclusion. An example of this would be, if the measure of angle A is equal to 15 degrees, then angle A is acute. And you can see the symbols there and how we read that. The related conditional statement that is easiest to write is the converse. All that you do is exchange the hypothesis and conclusion of the original conditional. So therefore we have, if A is acute, then the measure of angle A is 15 degrees. Notice what we have done with the symbols. We have just switched around P and Q. If Q, then P. The next related conditional is the inverse. This is where you negate both the hypothesis and conclusion of the conditional. So if the measure of angle A is not equal to 15 degrees, then angle A is not acute. So using the symbols, you can see that it's if not P, then not Q. And the final related conditional is the contrapositive. This is where you negate both the hypothesis and conclusion of the converse. So if angle A is not an acute angle, then the measure of angle A is not equal to 15 degrees. Symbol-wise, it's easy to see. If not Q, then not P. Let's give this a try. What are the converse, inverse, and contrapositive of the following conditional? And what are the truth values of each? If a statement is false, give a counterexample. So here is our conditional. If the figure is a square, then it is a quadrilateral. If we look at our hypothesis, the figure is a square, and our conclusion, it is a quadrilateral, we should easily be able to create our related conditional statements. Before we begin, let me start by remarking that our original conditional is true, and that will come in handy later. With that, let's start by talking about the converse and creating our converse. We create our converse by exchanging the hypothesis and the conclusion. So our converse should read, if the figure is a quadrilateral, then the figure is a square. Notice how I did change things a little bit due to the English language. We don't want to begin a sentence with a pronoun. It refers to the figure. So I replaced it with the actual noun. And then I used it later in the sentence. Really quickly, let's look at our truth value. Can you draw a quadrilateral that is not a square? Here is a four-sided polygon, and it is not a square. Therefore, the truth value of this statement is false. So our converse is false. A counterexample would be a trapezoid. Now let's look at the inverse. The inverse leaves the hypothesis and conclusion where they are. It just negates them. So the inverse should read, if the figure is not a square, then it is not a quadrilateral. So let's look at the truth value of this one. Can we draw a figure that is not a square, but it is a quadrilateral? Oh wow, a rectangle is not a square, but it is a quadrilateral. The hypothesis is true, but the conclusion is not. Therefore, the truth value of this statement is also false. And finally, let's look at our contrapositive. For the contrapositive, we negate the hypothesis and conclusion of the converse. So our contrapositive should read, if the figure is not a quadrilateral, then it is not a square. If the figure is not a quadrilateral, it doesn't have 4 sides, and therefore it can't be a square. So the truth value of the contrapositive is actually true. I'm hoping you noticed a pattern from our example. It will actually come in very handy when identifying truth values. And it is also helpful when discussing something called equivalent statements. Equivalent statements are statements with the same truth value. So if we go back to our original example of the angle, if the measure of angle A is 15 degrees, then angle A is acute. We know that's true because the definition of an acute angle is an angle with a measure between 0 and 90 degrees. The converse of that statement, if angle A is acute, then the measure of angle A is 15 degrees, is false, because an acute angle can be anywhere between 0 and 90 degrees. So just because angle A is acute, it doesn't mean that its measure has to be 15 degrees. You will notice that the conditional and converse are not necessarily equivalent statements. The inverse of our original conditional would be, if the measure of angle A is not equal to 15 degrees, then the measure of A is not acute. The truth value there is false, because the measure of angle A might be 37 degrees, and 37 degrees would still make angle A an acute angle. You will notice that the converse and the inverse are equivalent statements because they have the same truth value. And the contrapositive of the original conditional reads, if angle A is not an acute angle, then the measure of angle A is not equal to 15 degrees. And that is true, because if angle A is not acute, then the measure of angle A can't be between 0 and 90 degrees. You will notice that the conditional and contrapositive are equivalent statements. This is always true. The conditional and contrapositive are always equivalent statements. The converse and inverse are always equivalent statements. This is why being able to write these related conditional statements can help you determine truth values.